Hello, everyone. Once again, welcome to A1 Tutor Live class. Welcome back to physics class. So today we are going to be considering a new topic. We're going to be considering a new topic today. The last class, we discussed the topic friction, and we're able to explain the concept of friction, and also we consider the advantages and disadvantages of friction. We're able to consider that and the method to reduce friction, the method for reducing friction. That was the last class that we had, and we also had some calculation based on UTME on the topic friction. And today we are going to take a new topic, which is what you have on the screen here. Now on the screen here, we have different objects. We have different simple devices, let me call it that way. And all these objects here, or devices or instruments, when you look at them, they actually make work simple. They make work simple. All we have on this screen, we have the bicycle, we have the bicycle, we have the zipper, that is part of our clothing design. We have the slide, which children use at the amusement park. We have the axe, which is used for actually dividing a wood into two. We have the axe. We have the claw hammer also. Now, all these things we have there, we also have the gear. Now, if you look at all these things, they are what we use on daily basis. And what is actually their importance? Their importance is that they make work simple. They make work simple. And that leads us to the topic machine. It leads us to the topic machine. Or we say simple machine. Or we say simple machine. So today we'll be talking about simple machine. Now, all of these images we have here, imagine that we don't have all those things. How do we intend to do most of our work? Of course, most of those work are going to be very hard for us to do. So this instrument, these devices, this equipment has made work so easier for us. And that is why we call them machine. Okay? Machine is any device, any equipment, any instrument that make work faster, easier, that make work faster and easier. So today we are looking at that topic machine. We are looking at the topic machine. If you can hear me, please kindly signify and let me be sure that you can hear me. And if you can also see the screen, please kindly signify. Okay, for the sake of our followers who are unable to watch the last class video, which is friction, please do well to subscribe on our YouTube channel so you won't miss any of these videos. Once you subscribe, you'll be having access to notifications as we upload our videos. Please do well to press the subscribe button. Okay, press the notification bell and you'll be having updates of the recent videos we'll be uploading. Okay, thank you. So let's dive into today's work, machine. We are going to have the first part today, and next week we are going to continue. We want to discuss the topic machine. So we'll switch to our board. We're going to stop this presentation. Discussing the topic machine. Like I said machine is defined as an equipment, a device that makes work faster and easier. That makes work faster and easier. Now let's take an illustration. Someone is walking from probably his house to the school, and he's doing that by trekking, all right? By trekking. This is house and this is the school. So assuming that Mr. A is trekking to the school, is trekking, and Mr. B is going with a bicycle. Okay, is going to the means of a bicycle. That is cycling to the school. All right. So we have two individuals living the same house. We have the same distance. Okay, living the same house to the same school. The first person is trekking, while the second person is actually going with a bicycle. That is cycling. Okay. Now, between Mr. A and Mr. B, who do you think will be the first person to reach the school? Who will be the first person to reach the school? Is it Mr. A who is trekking, or Mr. B who went to the school by using a bicycle? Who will be the first person to be in the school? Your response? Is it Mr. A or Mr. B? Is it Mr. A that will be in school first, or Mr. B? I need your response. Of course, Mr. B will be the first person to reach the school. Why? Because he's actually using a machine. And what is the machine? The bicycle is classified to be a what? A type or an example of what? Machine. Okay? He will not just reach to the school first, but the journey will be more easier. The journey will be more easier because it will not be exhausting too much energy like someone that is trekking to the school. So we have it will make it faster for him, okay, and also it become what? More easier. So a machine is what? A device and equipment that makes work faster and easier, that makes works faster and easier. I believe we get that. So that is just a simple illustration of what a machine is up to. Okay, a machine will actually facilitate your work. A machine will actually facilitate your work. All right. So that is what we are discussing today, machine. Now let's have the definition of machine proper. Let's have the definition of machine. Permit me to clean the board. The definition of machine. Definition of machine. So let's evaluate this definition together. A machine or a simple machine is any device that make work easier, faster, and convenient. A simple machine or a machine is any device that make work faster, easier, and convenient. So you can see the three keywords. It makes it easier, it makes it faster, and also it makes it what? Convenient for the person. So a machine makes our work easier, it makes our work faster, and also it makes it what? Convenient. It makes our work convenient. All right. Now let me quickly give us an illustration of this definition, an illustration to explain this definition, how machines make our work faster and easier. How machines make our work faster and easier. Let's consider an illustration for that. How machines make our work faster and easier. All right, let's consider this. Now I believe we can see the screen. Now we have a gentleman working for a firm. As you can see, he's dressing up on the uniform for the firm. So what they are trying to do is that they are trying to upload some goods into the truck. Probably they want to go and deliver. Okay. And what you can see here is that this young man is actually doing his work in a smart way. He's making use of what we call an inclined an inclined surface, which also is an example of what? A meshing, an inclined surface. Without this inclined surface that we are having here, it will be so hard for him to transport those cartons inside the truck because we will need to carry them. Probably they are very heavy. We will need to carry them one after the other on his head, on his shoulder, and take it to the truck. It goes back again and do the same thing. But with the help of the machine, which is an inclined surface with this wheeled barrow, okay, is having a structured machine that makes the work easier for him. So he can actually carry 2 cartons at a time and push it through this inclined surface. Okay, push it through this inclined surface, and that will be very easy for him to do actually. If he's also going to be offloading the same set of goods, he's going to use the same inclined surface and push it downward instead of him carrying on his head or on his shoulder. That will be very stressful, that will be time consuming, and of course it's going to be slow compared to him using this simple meshing approach, which is the inclined surface and this wheel barrow. So I believe you understand now that machines are made to make work easier, faster, and convenient. Okay, so simple machines or machine are devices that make work easier, faster, and convenient. I believe that is clear to us. Please, if yes, let's signify. We are moving on. That is the simple definition of machine. That is the simple definition of machine. Can we proceed? If yes, please, thumbs up, and we'll move on to the next. Okay, so let's proceed to the next. We have types of machine. We have what? Types of machine, which we are going to be discussing one after the other. Types of machine. Types of machine. We have types of machine, and a summary of it types of machine. We have types of machine, types of machine, or types of simple machine. We have the first one, which is called the lever. The first type is called the lever. Is a type of machine. The lever is a type of machine. The lever is a type of what? Machine. Now, we are going to discuss the lever on its own because we have to consider the classes of levers. Now, what is example of a device that falls under the type of machine, which is a lever, is the scissors. The scissors is a good example of a lever. The scissors is a good example of a lever. We have the pulling system. That's the second type of machine. And this is the diagram, the pulling system. The pulling system. And this is the diagram of the pulling system. It's another type of what? Machine. We have the wheel and axis. The wheel and axis. That's another type of machine. And a good example is the ferry wheels. This ferry wheels is always found in the amusement park, and it makes use of this type of machine called the wheel and axis. The wheel and axis. Okay? So that is the third type of machine. The next one is the inclined plane. That was the one I used the other time to explain the definition of machine. Inclined plane. So you can see this staircase is exactly a good example of an inclined plane. An inclined plane. It actually makes the movement of probably some object through this place easier and faster. Even it makes the movement of someone that is on a bike, probably you want to carry your bike to this step, yeah? So you need this to walk through the process, okay? So inclined planes also is a type of machine. Then we have the wedge. The wedge. The wedge also is another type of machine. And a good example of the wedge is the axe. The axe that we use in actually probably cutting a wood into two parts. The axe is an example of wedge. Then we also have the screw. The screw also is an example of machine, is a type of machine. Yes, the screw also is a type of machine because it makes our work faster and easier. So we are going to be discussing these types of machine one after the other. But this is actually the summary of the types of machine we have. I believe that is clear to us. So let's pick them one after the other, and we'll be starting with the lever. And under the lever, we are going to discuss the three classes of lever, the three classes of lever. Then after that, we are going to take some calculation under the lever, some calculation under the lever. All right, so let's move on to lever, the classes of lever, the definition of lever. So back to our board. Permit me to clear the board. We want to take the definition of lever, types of machine or types of simple machine. The first one we are working with is the lever. So what is a lever? We want to have the definition. Okay, the lever, the definition of a lever. The definition of a lever. A lever consists of a rigid bar, underline the keywords, a rigid bar supported at the fulcrum or pivot. We call it fulcrum or pivot, about which it can rotate. So the fulcrum or pivot enables the lever to rotate, and effort applied at a point of the wheel. So that means on a lever, there's a need to apply effort. On a machine called lever, there's a need to apply effort at the point of the lever to overcome a resistance or lift a load at another point. So from the definition of a lever, it has to do with a rigid point that is supported at a fulcrum. So in a lever, we have the following. We have fulcrum, which is also known as the pivot. We have effort. We have load. So these three terminologies, or these three keywords, which is F, E, and L, has to be the key things we are going to be considering under lever. A lever is actually a simple machine that consists of a rigid bar supported by a fulcrum or a pivot about which it can rotate, that is the pivot or the fulcrum can rotate. Now let's make use of diagrams to explain that. The lever has three classes. We have three classes of the lever. I said it earlier that the lever is subdivided into three classes. The first classes, we have the representation of the first classes. The load is at this point. The force, which is also known as effort. Take note, the force is also known as what? The effort is at this point. And the fulcrum, which is also known as the pivot, is in between. These are the very technical questions that UTME are fond of asking. We said the first class of lever, the fulcrum is found dash in between the load and the effort, in between at the end of the load and the effort, at the beginning of the load and the effort. So you must understand the structure. So the fulcrum, which is also the pivot, is in between the load and the effort. So there's an acronym we use for this to make it very easier for you to remember. This is just going to be L, which is load, F, which is what? Fulcrum, and E, which is what? Effort. So LFE, LFE is the first class of what? Lever. That is, the fulcrum is in between the load and the effort. The fulcrum is in between the load and the effort. And I said the force here also represents the what? The effort. Now, what are the examples of devices or simple machines that are found under the first class of lever? We have the hammer, the claw hammer. The claw hammer is a perfect example of the first class of lever, the claw hammer. Now, this is the effort, and this is the fulcrum, and this is the load. So if I'm going to write this, it's going to be L, the first one, F, and E. So it follows the acronyms: load, fulcrum, effort. So the fulcrum has to be at the middle. It has to be in between the load and the effort. So the claw hammer here, the fulcrum is at this point, and the load is where the nail is. You know, you're trying to pull out a nail, probably from a wood or from somewhere. So then the nail, where the nail is, that claw mouth of the hammer happens to be where the load is going to be, and that load is the nail. Now, where you are applying force is where your effort is. And actually, this is where you are applying the what? Effort. You are applying the effort at this place, exactly this place, where you have what? Letter E. So that is the first example. We also have another one, which is what? The plier. The plier is also another example of the first class of lever. The first class of lever. We have the load at the mouth of the what? The plier. The load in between the mouth of the plier. Then we have the fulcrum. This is the load. We have the fulcrum here, and we have the effort here. So you know, when you want to actually make use of a plier, the mouth is like this. So here is where you have your load. Okay. Now there's a part that looks like it is fixed. Okay, that connects the two. You know, the plier is just like a combination of two things together, just like that of a scissors. Okay, so where you have that bolt that connect the components of the plier together is your fulcrum, where you apply the effort, your force, while pressing the plier is now called your what? Your effort. So if you look at this arrangement also, you have the load first, the fulcrum, then you have the effort. Follows the what? The arrangement of first class of what? Lever. So the first class of lever, take note, is very important you understand this and have it in your mind. It has to do with the fulcrum in between the load and the effort. The fulcrum in between the load and the effort. So it is a question that actually come out in UTME exam. I believe that is clear to us. If that's clear to us, please kindly thumbs up. Okay, now let's proceed to the second class of lever. The second class of lever, we have the force. We have the force. We have the load. We have the fulcrum. So the acronyms for the second class of lever is fulcrum, load, effort. Fulcrum, load, effort, which implies that the load is in between the fulcrum and the effort. The load is in between the fulcrum and the effort. As you can see here, the fulcrum will come first, and the load is in between the fulcrum, which is the pivot also, and the effort. The effort also is the same as the force. And under this second class, we have some example also. We have the wheelbarrow. The wheelbarrow is a good example of the second class of lever. This place here, the wheel here, is said to be the fulcrum, and where you put your load here is said to be the load, letter L, and where you actually carry it to push is called the what? The effort. It's called the effort. So we have the acronyms F, L, E. The load is in between the what? The fulcrum and the effort. The load is in between the fulcrum and the effort. Now we have the nut cracker also. Another example is the nut cracker. Okay, this point here is the fulcrum, and inside it, that is where you put the load. The nut cracker, you have to put the nut inside the device to press it. Okay, so where you put the nut is inside, and that is where we have the load, letter L, the load, and where you actually apply the force, where you apply the effort, is this point, which is called the what? The effort. The effort. So we also have the same arrangement. The first letter is F, followed by L, followed by E. So the load is in between the what? The fulcrum and the effort. The load is in between the fulcrum and the effort. Let's take a pause. Okay, please, if this is the first time that you are watching our videos on YouTube, please do well to subscribe. Okay, press the notification bell so you can have updates of the videos as we upload them on our YouTube channel. Do not forget also, please kindly share and also comment on our YouTube channel. Thank you. Let's proceed to the third class. The third class is the fulcrum comes first, followed by the force, then we have the load. All right, so we have the load. Now, the arrangement of this will be F. Okay, don't let us use force. Now let's use effort instead of force. So we have different alphabets. We have fulcrum, then we have effort, then L. That is F-E-L. The effort is in between the fulcrum and the load. The effort is in between the fulcrum and the load. The effort is in between the fulcrum and the load. And a perfect example is our hand. Okay, this is the fulcrum. This is the fulcrum, and this is the load. The load is at the end. The fulcrum is here, and this is where you have the effort. And the example we have here, this is the diagram here. The fulcrum is the joint we have here, and this, which represents the load, and this, which represents the effort. So the arrangement of this, we have first the fulcrum, followed by the effort, then the load. So the effort falls in between the fulcrum and the load. The effort falls in between the fulcrum and the load. Then we have another example, that's the sugar tongs. Okay, the sugar tongs. Here is where you put the cube of a sugar, and that cube of the sugar serves as the load. This is the load, all right? And at the edge here, we have the fulcrum, which is also known as the pivot. Now, these points, this particular place where I use the arrow to indicate is now the effort. So we have fulcrum first, followed by effort, then load. So you can see the equation now. You just need to know these acronyms to make it very easy. First class is LFE. This works with the first class. The second class is FLE. E. This is the second class. The first class is L, F, E, while this one is F, L, E. Okay? And the third class is F, E, L. The effort is in between the fulcrum and the load. The load is in between the fulcrum and the effort. The fulcrum is in between the load and the effort. So the first class of lever, we have the fulcrum in between the load and effort. The second class of lever, we have the load in between the fulcrum and effort. And the third class of lever, we have the effort in between the fulcrum and the load. So this is the code for you to what? Retain the class of what? Lever. The class of lever. I believe that is clear to us. If yes, please signify by thumbs up as we move on to the next. Signify by thumbs up as we move on to the next. Okay, let's proceed now to the next. I'll stop presenting this. Now we've explained what a lever is, and we've considered the classes of a lever. Now let's take the next type of machine. The next type of machine. Permit me to clean the board. The next type of machine. We are still under the types of machine. So let's consider the next type of machine, which is the pulling. The next type of machine, which is the pulling. The next type of machine we are going to consider, number 2, is the pulling. The pulling system is a machine that is commonly used to raise heavy loads, to raise or lower heavy loads, especially in construction sites, especially in construction sites. If you are very conversant with construction sites, they actually use what we call the pulling system. Now let me show you the diagram of what it looks like. The pulling system, how it looks like. So this is a picture of the pulling system. Now this is what we call the pulling system, where you have the loads, you have the load here, and the aim of using the pulley system is actually to facilitate your work. And as we said, in this construction site, the pulling system is used to actually carry probably blocks or load of sand up to where the construction is going on. And sometimes also, it is also used to drop some other quantity or some other materials on the site while constructing houses. And this is what they actually design. Okay? We have a rope that will be tied around a particular pulling. The pulling is this. What you have here is called the pulling. This is called the pulling. Let me identify that. This is what we call the pulling. So it becomes a pulling system when it is used to make work easier and faster. Then we refer to it as what? A pulley system. A pulling system. Now this diagram, we are going to be counting how many pulleys we have. Of course, it has been written here. If one of these is called a pulling, that means you have 1, 2, 3, 4. So we have 4 pullings here. And for this, we have 1, 2, 3, 4, 5. We have 5 pullings. No matter the size of the pulling, we still have to count it. Okay? So the pulling system is used in construction sites mostly to what? To bring some object up to where the construction is going on, or to lower some objects down on the what? On the ground. So that is what we call the pulley system. And you know, it makes work faster in building constructions. It makes work faster. We will now compare a building site where they are using a pulley system to draw the cement or to draw the sand or the block while building, and a construction site whereby they have laborers that are carrying the cement to their head, and they will walk through a particular part, getting to the top, dropping it, coming back again. That is going to be a kind of time wasting. Of course, they will achieve the aim of constructing the house, but it's going to consume time, energy, and it's going to require many laborers. But when you are using a pulley system in construction site, it makes the work easier. You just need someone to be drawing the rope to make sure the object or probably the load comes up, and also release it back to the ground for another load to be sent upward. So this pulling system faster, makes work faster, easier, and what? Convenient. It makes also work convenient. It makes work convenient. Okay, so this is the pulling system, and is also a type of machine. It's also a type of machine. We are going to be considering some calculations on the pulley system and also the lever. Let's write on to the next type of machine. We have more to discuss. So let's consider the third type of machine now. The third type of machine that we have the inclined plane. The inclined plane. That's the next type of machine that we want to consider. The inclined plane. Okay, the inclined plane is another type of machine. The inclined plane is a machine used to move heavy loads from a lower to a higher level. From a lower to a higher level. From a lower to a higher level. Is that a simple inclined plane can be constructed by a slopy plank. So when you have a slopy plank that is positioned in an inclined position, it has already bring what we call a simple inclined machine. Okay, so we have the functionality of an inclined plane is to take load from lower to higher, and of course it's not lower to higher alone, vice versa, higher to lower, and also higher towards lower. So when you have an inclined plank of this shape, and probably you are taking a load to this place, a load on this inclined surface, what you have just done is a simple machine, which is called an inclined plane. Let's consider a diagram for that. How does an inclined plane looks like? Okay, an inclined plane, this is a perfect example. From lower to higher, that was the definition we said the other time, that an inclined plane is used to carry loads. This is, of course, this is a load. From lower, this is lower, to higher, up to this level. This is the higher. Okay, so what we have here, this that we have here is an inclined plane. This is what we call the inclined plane. All right, this is what we call the inclined plane, and the usefulness is to carry load from this lower level to the higher level. Do you know how convenient it's going to be for this young man as he's doing his work? It's going to be very easy for him to what, carry as many load as he can, and he will not get tired because actually there is a very um, faster way of carrying those loads by using this inclined plane. Imagine if he was carrying that same quantity of load on his shoulder or on his neck, walking to the truck, offload it to the truck, come back again, pick another one. He's going to be exhausted, of course. He's going to be exhausted because it will require too much of energy, that is, too much of effort to be required, and it will not be faster like using this inclined plane. So this is a good example of inclined plane, and this is actually the concept behind the inclined plane. This is load. Here we have the load, and you have to apply, this is another, you have to apply a force trying to push the load to the higher level. This is the lower level. From the lower level to the higher level, that was what we said. From lower towards the higher level. And this is the load. So force is needed to be applied. Force is needed to be applied to push through this what? This load to the higher level. And you can see that the inclined plane, one thing you need to know about the inclined plane is that it forms a right angle triangle. The inclined planes forms a right angle triangle where you have this to be what? 90 degree. When you have this to be a 90 degree. So the inclined plane must form an angle with the ground. So if this is ground, if this is the ground, this place is going to have an angle. And that is based on how the plank or the arrangement of the inclined plane is being done. That will determine the angle formed with the plank and the ground. So theta is going to be an angle that is formed by the plank and the ground. Okay? Why this place is angle 90. So this is the concept behind an inclined plane. The usefulness is to push us to, or is to lift loads from the lower to the what? Higher. From the lower to the higher. That is the usefulness of the inclined plane. Okay, let's move on to the next type of what? Of machine. The next type of machine. This is the third one. We are moving to the next one. The next type of machine that we have. We've talked about the pulling. We've talked about the inclined plane. We also talked about the lever. Now we want to pick the next type of machine. What's the next type of machine we are going to consider? Still on types of machine. The next type of machine to consider is the wedge. Number 4, we are going to consider the wedge. That's the next type of machine. The wedge. So the fourth type of machine that we are going to consider is what we call the wedge. The wedge is a combination of two inclined planes. The combination of two inclined planes is called the wedge. It is used to separate bodies which are held together. It is used to separate bodies which are held together by a force, by a large force, such as splitting of timber, such as splitting of timbers. The wedges of an axe, a chisel, a knife. So the example of wedges is we have an axe, a chisel, or a knife. Now, the definition of a wedge is the combination of two inclined planes. You know, we said this is an inclined plane. All right. So when you have two of these combined together, it forms the wedge. It forms the what? The wedge. And let's look at the diagram of a wedge. The diagram of a wedge. So we can explain using the diagram. Okay, this is the diagram of a wedge. Now, the combination of two inclined planes. Let's explain that. This is the wedge. If I'm to dissect this into two, trying to divide this into two. Now I have this is an inclined plane. This is another inclined plane. So two inclined plane joined together, combined together, forms the what? The wedge. This is an inclined plane and another inclined plane. So the two joined together forms the wedge. All right. Now this is the wedge. How it looks like. It always have a sharp. It has a sharp edge, which is this point. It has a sharp edge, and that is why it is mostly used to actually divide or separate a particular object. And the example that was cited the other time was a timber. If you are to separate a timber, you are going to use the wedge. People that work in factories where they deal with timber, if they want to actually separate a very big timber, they make use of the wedge. They will put the wedge on that timber and use the hammer. Apply heavy force. Heavy force is required to ensure that the timber is what is divided or separated into two. And this illustrations explains it. This illustrations explains it. We have the wedge. This is the wedge. And let's take this as the timber. This is the timber. Now applying a force with the hammer. Applying a force with the hammer. Let's say this is the timber. This is what? The wedge. And this is where you apply the force using the hammer. So the more you hit on top of the wedge, you are applying force. And where you are going to feel the output of your force is on the timber. The timber will start separating. The timber will start separating. So that is why it is called a machine. The wedge is called a machine because imagine if the wedge was not existing. How do we intend to divide a what? A timber easily? It's going to be a kind of very tedious work if that wedge is not being used. So the wedge makes it faster, easier, and what? Convenient. These three key informations are needed when you define a what? A simple machine or a machine. Now let's look at some other examples of the wedge. Some other examples of the wedge. Yeah, examples that are related to the wedge, we have the axe. Now look at the mouth of the axe. It's exactly like the wedge that we just discussed earlier. You know, the wedge looks like this, having a sharp edge. So this also here represents the wedge. And that is why the axe is very easy. It's very easy to use the axe to what? To actually cut your wood and divide them into two. Okay? Another one that we have is the one we are very close to in the kitchen, the knife. If you look at this portion of the knife, it also have the shape of a wedge. And that is why it's very easy to dissect, okay? To dissect your onions, dissect your tomatoes in the kitchen. It is because the knife is classified to be a wedge, a simple machine called a wedge. So it is easy to cut or to divide some things in the kitchen with what? Your knife. It is easy to dissect your birthday cake with your knife. because it is classified to be a wedge. And a wedge is to separate a load. Separate a load. We have the what? The saw. The saw also is an example of the wedge. The cleaner or the sharpener is also an example of a wedge. And that is why when you dip in the pencil inside the sharpener, you notice that some particles will drop in and the mouth of your pencil becomes more sharpened. So the design of the sharpener is just like the design of the mouth of an axe. So it also has a what? A wedge at this portion, which actually help you to train your what? Your pencil. The shovel also has the design of the wedge at this particular point of it. And also the zipper. The clothes we wear has the zip. So the zipper, this is the zipper, also has the structure of what? A wedge. So all these examples of what? Of wedge. They are all examples of what? Wedge. So these are the examples you can relate with within our environment. Examples of what? Wedge. Now let's proceed. We'll stop presenting and we'll move to our board. Okay, so we've discussed number 4, or that should be number 5 now. Number 4, which is the wedge. We've discussed the lever as a type. We've discussed the inclined plane as a type. We've also discussed the wedge as a type. We've discussed the wedge, and also we've discussed the pulling system. Also we've discussed the pulling system as a type of what? Of machine. Today we are going to stop here and we'll continue the next class. We are going to take part 2 of simple machine by next week. But today we are going to stop here. We are going to stop here for the class today. We've been able to treat lever, inclined plane, wedge, and pulling. So next class, we are going to take the remaining types of machine that we have and we'll proceed with the other subtopic. Okay, so today we have been able to define what a machine is, and we said a machine is a device that makes work easier, faster, and what? Convenient. Those 3 key informations is expected to be inside your definition: easier, faster, and convenient. So if you are making use of a machine, you're expected to have conveniency in doing your work. Okay, so we define machine. We also went ahead to explain the concept behind machine and why machine is necessary. We explained that with some pictures. Then we went ahead to discuss the type of machine, under which we discuss the classes of lever that we have. We said we have 3 classes of lever: the first class, the third class, the second class, and what? The third class. And we gave acronyms to all of them. We have FAIL, we have this also, and we have the next one, which is this. And we said here that the effort is in between the load and the fulcrum. The fulcrum is in between the load and the effort, and here the effort is in between the load and the fulcrum. So we discussed the classes of lever, and we also make use of some image to explain what the classes of lever are. We made use of some image to explain the classes of lever. And we also cited examples of the classes of lever. We said under the first class of lever, we have the scissors. Under the second class of lever, we have the wheelbarrow. Under the third class of lever, we have the shovel. So all these are the things we discussed today. So next week, like I said, we are going to continue this topic. So ensure you do not miss any of the live session class next week. Make sure you make yourself available and join the class on time. For our YouTube followers, please always stay tuned for the classes, and also follow us on YouTube so you can have the latest update of our videos. As we upload our videos, you'll be receiving notifications of our videos for all the subjects we offer. Ensure you always subscribe to our YouTube channel. Share, like, and comment. Thank you, and thank you for your time. We are going to meet again next week. Bye. And also tomorrow, do not forget our classes continues. We have English class and mathematics class. Ensure you are online to follow the class. And ensure also that you subscribe to have the full details of all of our classes on YouTube. Thank you for your time once again, and we'll meet next class.